Hello everyone. So the key element of any of those alert systems is the conflict detection and resolution methods that are embedded. So the information flow would be something as in this figure, right? We have the environment, 3, 4 number of flights that we need to send somehow, and we would do um, getting the information from different sources, some sort of estimation about the state, position, altitude, velocity, and this depends a lot on the type of sensor we are using the type of, for instance, radar mode we are using. Once we have an estimate of our state using a dynamical model, we would be predicting future status or future state of our aircraft. Right? This might be familiar to you. By defining a metric, in principle, the conflict violation, this 5 nautical miles in the horizontal plane and 1,000 feet in the vertical plane, we can detect and then eventually resolve conflicts, and always, right, in interaction with the human operator. So we can either detect and provide information to the human operator, and the human operator is instructing information and feeding back to the environment. That's one option. The other option is that we detect, then we call conflict resolution routine, and then the conflict resolution routine provides to the user or interacts with the user and provides an avoidance strategy, right? And then the operator is the one to implement that strategy that has been suggested or not, and then again is feeding back. There is a survey paper, very old, 20 years old, that reviews conflict detection and resolution models that you can take a look if you want. And now, if we take a look at the type of methods that have been proposed in the literature to tackle this problem, we can possibly divide them into two branches. Right? On the one hand, we have those that rely on optimization, and you have linear programming approaches to this problem, mixed integer linear programming approaches to the same problem, non-linear programming approaches to the same problem, even mixed integer non-linear programming approaches. Right? We have been already using linear programming and mixed integer linear programming for tackling all the type of problems, flow management, arrival manager, cruise scheduling, etc. And in this particular case, we will be moving to nonlinear programming. The good thing of nonlinear programming is that we can incorporate nonlinearities, and thus we can model the aircraft as an aerial vehicle, right? So our aircraft is a real aircraft that is flying, because with linear programming or mixed linear programming approaches, in the end we are not considering a real aircraft, right? A real aircraft we cannot turn, it doesn't embed dynamics, speed dynamics, for instance. Thus is less accurate, but of course it's easier to solve in principle. We will see some aspects about this. The other type of, or the other branch of methods has to do with heuristic, meta-heuristic. Also, nowadays it's very trendy to call it artificial intelligence. You will see this word around. But in any case, we are searching for solutions that are close to optimal. The strategy is somehow random. It doesn't follow any mathematics, because in optimization we are always computing gradients, right, and finding zeros, some functions. Here is more based on trial and error, on some kind of experience, somehow That's heuristics, right? To find. And here we have neural networks, simulated annealing, genetic algorithms. Right? Sometimes it's being inspired, right? Taboo search, we have ant colony, etc., etc., etc. There's a wide variety of approaches to tackle the problem, and this is becoming more and more trendy because computers are more and more powerful, and this trial and error and this searching, in the end, is very efficient today. But mathematical proofs underneath are kind of weak, right? So in the end, two different methods that we can compare, and both of them might be suitable to actually solve the problem. All the type of papers you can check. You can check this paper. This is a survey. Again, it's 10 years old, not 20, so a bit more recent. And we have also this book in which this survey paper goes more into optimization approaches, whereas this other book is relies more in artificial intelligence approaches. So both might be interesting books to check. Now, if we focusing on optimization, we were seeing that if we detect a conflict, we have three ways. The controller has three ways of solving the conflict: speed, heading, or vertical advisory. So we can model the problem in different manners, proposing velocity changes, proposing heading changes, combining velocity and altitude changes, velocity and heading changes, or even combining the three of them. And you see here three papers that implement some of these approaches. Right? These papers are fully based on linear programming and mixed interlinear programming. And in our case, we're going to move into including velocity and not velocity and altitude, but velocity and heading changes using nonlinear programming. And this is what we intend to do in the next two sessions in the lab, and we'll see some examples. So thanks very much for that.